Hi everyone, welcome back. So in this video here, we are going to discuss molecular representations, different ways of representing molecules in organic chemistry. Now this topic is in chapter 2, but I'm actually jumping into it because once we do it, it would make our life really easy, okay, to draw these molecules out. Because as you practice problems on Lewis structures, what you would realize is that with every extra carbon that's added, the bigger the molecule gets, drawing out these structures becomes more and more cumbersome. So to avoid all of that, that hassle of drawing really bulky, cumbersome molecules where every bond is drawn out, we have different ways of representing the same molecule. And some of them are much more easier and straightforward than others. And in fact, for the remainder of this course, we will not be using Lewis structures. We are going to transition to bond line structures. That's how we will be representing molecules going forward. Okay, so I'm going to draw out some examples, and then I'll show you how the different representations are related to each other. So let's go ahead, start out with some Lewis structures, and then I'll show you the other representations. So let's consider a molecule where we have a carbon, and we have double bond, hydrogen, two hydrogens, and like that. Let's say that's one molecule that we're going to consider. Another molecule is carbon with three hydrogens, two hydrogens, two hydrogens, two hydrogens of carbon. So these are two Lewis structures that I'm going to use as examples for the different molecular representations that are possible. So the first molecular representation that we're going to draw here is called a condensed. It's called a condensed structural formula. Okay, a condensed structural formula. So what we do in a condensed structural formula is we actually condense this molecule a little bit. We shrink it a little bit. So if you look at this carbon here has three hydrogens to it. So that can be drawn as a CH3. And then that carbon is connected to a carbon with two hydrogens to it. So we'll show that bond, and we can write CH2 because that's a carbon with two hydrogens to it. And then it's connected to a carbon with a double bond to an oxygen. So we're going to draw that out. And again, sorry about this, because it's a Lewis structure, we should have some lone pairs here. So that oxygen has lone pairs to it. And then we have a nitrogen with two hydrogens to it. So we can condense that down and then show the lone pairs. So now this structure is much easier to draw compared to that original Lewis structure. We've actually cut down on a lot of drawing, like the bonds. But what's important is, even when the molecule is drawn in this condensed structural formula, we should be able to read the number of bonds and everything. So this CH3 with a bond to this carbon is read as that carbon is connected to this other carbon, and that carbon has bonds to three hydrogens. So we should be able to visualize a Lewis structure from a condensed structural formula. Now, you can condense it down further, in fact. Okay, so this is one representation of a condensed structure formula, but you could just condense it down further and just write this as CH3, CH2, C double bond O with an NH2, let's say. This could be like another condensed representation. And what I've done here is we haven't even shown the bond between these carbon atoms, okay? CH3, CH2, you have C double bond O, and then NH2. So this implies that this carbon is connected to 3 hydrogen atoms, like here, and it's connected to that carbon atom. And that carbon is connected to 2 hydrogen atoms, like here, and it's connected to both of the other carbon atoms. So that's what's implied here, okay? And then the representation that we will be using mostly is called a bond line structure. This is the simplest of all, and it makes the structure easier to write. And then once you get used to it, it's easier to read as well. Okay, so in a bond line structure, what happens is the carbons and the hydrogens on a carbon are not shown. So you do not show the carbon or the hydrogens to a carbon. Heteroatoms like oxygen and nitrogen, so any other atom is shown, and hydrogens on the heteroatom like a nitrogen or an oxygen are also shown. So this same structure here, or this structure here, or this Lewis structure here will be drawn as let me draw both forms. So it will be drawn like this. Now, in a bond line structure, each endpoint and each corner represents a carbon atom, but the carbon is not shown. And notice how bonds to hydrogens or the hydrogen atom is not shown. So if I look at this endpoint here is a carbon atom. And this carbon atom has one bond to it, which is shown. It is bonded to another carbon atom here at it is bonded to another carbon atom here. And since this carbon at the end point has one bond to it, it should have 3 more bonds to it. And those 3 bonds are to 3 hydrogen atoms. So this end carbon would be read as this CH3 or this CH3 or that CH3. And then this carbon in the middle here, okay, that is the CH2, because this carbon has 2 bonds to it. So it is missing 2 more bonds, which are not shown, and those must be hydrogen atoms. So this is a CH2. And this carbon here, okay, this carbon here has 4 bonds to it. It has 1 bond to the nitrogen, 1 bond to the carbon here, and it has 2 bonds to the oxygen. That means it has all 4 bonds. So there are no hydrogens on that carbon atom. Okay, notice how the hydrogen atoms on the nitrogen atom are shown. Okay, so this is one representation. Now this molecule could as well be written like this. These are not different, they are the same. So end point is a carbon atom. Inside here, every bend that you see, that is a carbon atom, oxygen, nitrogen with 2 hydrogen. So these are the same molecule. Okay, so every endpoint in that structure and every corner in your structure, that is a carbon atom. Every endpoint and every corner is a carbon atom. Hydrogen atoms are not shown. So now let's go ahead and try the same thing on this structure here. So if I look at this molecule, we'll first do a condensed structural formula, okay? And then we will do a bond line structure for that. So if I have to do a condensed structural formula for this, I can write this as CH3, CH2, another CH2, another CH2. So you have 1, 2, 3 CH2 groups, 1, 2, 3 CH2 groups. Then we have a CH, and then a double bond and a CH2. So this condensed structural formula represents the same molecule at the top, a loose structure. But much easier to draw because we're cutting down on a lot of bonds that need to be shown. In fact, we could make this better. We could draw this as CH3 and then CH2. And now notice there are 3 CH2 groups, okay? 3 CH2 groups. So we can put this CH2 inside brackets in parentheses, and then we can write thrice, which means there are 3 CH2 groups in a chain. That's what this means. And then we have CH, double bond, CH2. So that would be a further condensed structure for that molecule. Okay, so they're both condensed structural formulas. Now we can go to a bond line structure. So let's count the number of carbon atoms here. We have 1, 2, 3, 4, 5, 6 carbon atoms. Okay, so for the bond line structure, I'm going to start at an end point. I'm going to be, this is 1 carbon. So I'm going to start here 1, 2, 3, 4, 5, 6. 1 carbon, an end point is a carbon atom. Every corner is also a carbon atom. So you have 1 carbon, 2nd carbon, 3rd carbon, 4th carbon, 5th carbon, and 6th carbon. 1, 2, 3, 4, 5, 6. That's how many carbons we have. Now, there is a double bond between the carbons at the end. So I'm going to put a double bond right there. And that is a bond line structure for this molecule. None of the hydrogens are shown. None of the carbons are shown. There is no heteroatom here, like an oxygen or a nitrogen. There's nothing there. So it's basically a zigzag chain. Every endpoint and every corner represents a carbon atom. And how do we read this? This carbon here, this endpoint here has 1 bond to it. So it must have 3 hydrogens to it. So it's a CH3 group. This corner has 2 bonds to it. So it should have 2 more bonds to it. It is a CH2 group. This endpoint over here has 2 bonds to it. There's a double bond to it, to that endpoint, which means it has 2 more hydrogens to it. So it is a CH2 group. This carbon here has 2 bonds on the right, 1 bond on the left, total of 3 bonds. So that carbon must have 1 more bond to it. It's a hydrogen. So there is a hydrogen over here. So that's how we read this. And so drawing these bond line structures actually makes it very easy to draw these organic structures. And as our molecules become bigger and bigger and we have to draw more and more of these, it saves a lot of time. Okay, so please practice the recommended homework, and then you can convert these convert one molecular representation to another. And as I mentioned, we'll be using mostly the bond line structures in a bit. We'll just start using bond line structures more and more.